Good evening, sir. Okay. Good evening, everyone.
Good evening. Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, ma'am. So I hope I can start the session. Yes. Shall I?
Yes, ma'am.
Yeah. So a very good evening, everyone. Today is the day 2 of this 7-day FDP, where I'm going to discuss. Today I'm going to discuss the reliability and the normality part, right? Yesterday I discussed the basics of SPSS. There I have also talked about what is the research, what are the various components of research. We have seen the variable there, and we have seen the measurement scales, right? Apart from that, I explained you the types of hypothesis, or what is the means when to frame, or what type of hypothesis, what are the various types of hypothesis that we can develop or we can formulate, right? So this was the agenda. Yesterday I discussed. Apart from that, also I have shown you the interface of SPSS. We have seen there that how to define variable, right? And then I have explained you few of the things like that. Any question? So I think I discussed then that we have seen the recording also, that how you can record the data. This is what we have seen yesterday, right? Today I'm going to talk about the thing that is the reliability and the normality. So as the pedagogy, I already declared, or I already communicated to you people, that I will discuss the conceptual aspect first, and then I'll talk about the how we can perform that thing using the SPSS. So I am starting with the presentation part first, and then I will talk about the working of normality and reliability in the SPSS, that how you can perform these, right? So I have shared my screen. I hope my screen is visible to everyone. It's visible.
Yes.
Yes, ma'am.
Okay. Thank you so much, ma'am. So day 2, I'm going to talk about the 4 things here. Agenda is reliability. I will discuss, that is what is the reliability. Second, I'll discuss what are the different methods and the types of reliability. Then we will talk about the second agenda, that is the normality, and we will see what are the various methods which we can use to check the normality of any variable, right? So I'll start with the first thing, that is the reliability. So when we talk about reliability, whenever we say reliability, reliability is nothing but when you are saying the particular thing is same or consistent, that way that particular thing becomes reliable for us, right? So same is the case of reliability in the statistics also. When we talk about the reliability, we are checking the reliability of, first thing is the questionnaire, right? Which we have the questionnaire. Using that questionnaire, you can collect the data and then you can check the reliability. So scale, questionnaire, or instrument, all three is nothing but is the meaning is very similar, right? So whenever you want to test the reliability of the whenever it is being asked to the you that check the reliability. So we will check the reliability of questionnaire, whether the questionnaire is consistent or not, right? So I'll start with what is reliability. What reliability is nothing but it is a measure of consistency, right? So when I'm saying I'm using a same questionnaire again and again, if the same questionnaire is giving me the same results, that means that particular questionnaire becomes consistent and becomes a reliable for me. So consistency is nothing but when the questionnaire or the instrument is producing the same result again and again, it becomes the reliability thing, right? So this is known as the reliability. Second question comes, when to use reliability. So the answer is very simple. Whether you are having the Likert scale data or any non-Likert scale data also. In both the cases, you can check the reliability of the questionnaire. Next, Where you need to apply the reliability, where you need to check the reliability. So the answer is whether you are using your own scale or you are means whether you are using the existing skill or whether you are developing your own skill. In both the cases, you need to check the reliability. So I think those who are in research, I think many of you are there will be in the research, and maybe some of you are starting your career in the research field, right? So if you are having the idea of the research field, if you are developing research papers, you are writing your thesis, maybe you are already PhD or something, so you know in in the field of research, there are so many skills which are already developed by the previous people, previous researchers, right? We can use their skills. And if you're using their skills, even then, because if the skill is developed, that means it is already reliable skill because it is tested by the persons, those who have developed that skill, right? But the thing is, if you are using same skill for your purpose, even then you check its reliability. Answer is very simple because if you are using reliability or if you are using a skill for your own purpose, so possibility is that because we are not using the skill in the same context, maybe same reason is not there, time period can change. So there are multiple factors which are impelling you or which are indicating you check the reliability of your skill or of your questionnaire, right? So if you're using the existing scale, even in that case, you need to check the reliability. Second is if you are developing your own skill, if you're developing your own questionnaire, right? So if you are referring the literature, you are identifying the variables, and that if you are making making your own skill, your own questionnaire, even in that case, also you need to check the reliability of the skill, right? The last question is how to check the reliability. So the answer is very simple. Whenever I'm talking about checking of the reliability, so there are dedicated methods available. Using those methods, we can check the reliability of the data, right? So now we will talk about the types and the methods of reliability. Firstly, I'll talk about the types of reliability. So broadly, if I say, we can divide reliability into the two parts: stability reliability and the internal consistency reliability. So when I'm saying that the scale is stable, means whether it is in context to the time or in context to the reason. So if your scale is referring or giving you the same results, it is known as the stability type of reliability. Internal consistency reliability is the most important reliability because in the internal consistency reliability, what we are checking the that whatever items we are, or items meaning the questions, that whatever questions we are taking on a scale, those questions should be interrelated to each other, right? So that way you can say we are going to check the internal consistency of the scale. So this way, these are the two broader aspects of the reliability, that is stability and the internal consistency. Further, talking about what methods you can use to check the reliability. So there are four methods: test, retest reliability, parallel form reliability, split half reliability, and internal consistency reliability, right? First two generally we are using for the stability type of reliability, right? Whenever you want to check whether your skill is reliable or not, whether your skill is stable or not, you can use parallel form, and the rest test, retest reliability, right? Further, remaining two we are generally using for the internal consistency. So we will understand all four one by one. First, I am taking the test, retest reliability. So test, retest reliability is nothing meaning whatever reliability we are applying, whatever methods we are applying, every method will give you the value of the correlation, right? And that way we are checking that the quotient value should be sufficiently large so that you can conclude that the scale is the reliable scale, right? So I think in the word form you can find so many things I have written on a slide, but I tried to convert all these text into the diagram form. So you can see the diagram is this, which I just developed, which I have developed for you people. Means it is not you will not find this type of diagram in any of the books, right? But this is I have developed using the theoretical part. So here you can see test, retest, reliability. So in that case, you can see it will start from here. Test meaning is what? That is your questionnaire, right? Whatever questionnaire you are having, that is known as test. So what you need to do, you need to administer or you need to circulate your test to a particular group of respondents or particular group of people, right? after the sufficient time gap, that is, it can be approximate maximum 6 months gap, right? And then you can circulate the same test to the same group of people, right? So same respondents will answer or will give the response to the same questionnaire after a sufficient time gap. Means it is like because it is, I think, being a human, we understand it is a human mind. So maybe today I have responded to a particular question. If you will ask me tomorrow, so possibly I can recall what I have marked. But if there will be a gap, so might be I will forget the thing that whatever I have marked, I will not be able to recall that, right? So that way you need to take a sufficient time gap, and then you need to again administer the test on the same group of people, and you will collect the scores for whatever 2 times you are conducting the test. On both the conducts, you will collect the scores, and then you will check the coefficient of correlation value of that. In both the scores, you will calculate the coefficient of correlation. And if this coefficient of correlation comes greater than 0.7 or above 0.7, you can conclude this thing that your scale is the reliable scale. That means your scale is stable and it will produce the same results if you will use the same scale again and again. Second one is the parallel form reliability. Parallel form reliability, again, you can find this is written in the text form. Using the diagram, I'll explain you this. So in the parallel form reliability, what you will do, whatever test or questionnaire you are having, you will divide that into the 2 parts. Part 1, you will give to the certain number of people, and then what you will do, you will take a certain time gap. We suppose it says it may be for a 1 month, 15 days time gap you will take, and then to the same group of people you will give the second part of that test, and then you will collect the scores in both that both the conduct and the part 1. Whatever scores you are getting, whatever score you are getting, that you will mention, right? That you will what I can say, you will record that, and then in the second part also the scores whatever the marked by the respondent, that you can record. And then in both the scores you will find the coefficient of correlation, and if this value comes greater than 0.7, that way you can conclude that your scale is the reliable scale according to the parallel form reliability. Next one is the split half reliability. Split half reliability is here, rather than dividing the scale or the questionnaire in the 2 groups, this time we will divide the respondents into the 2 groups, right? So we will divide the respondent into the 2 groups, and then we will give the both the groups at the same time, right? And then we will collect the scores from the 2 groups, and we will identify or we will calculate the coefficient of correlation in those scores. And if this value is greater than 0.7, that way you can conclude that your scale is reliable scale according to the split half reliability, where you are splitting your respondents into the 2 groups, right? So this is known as split half reliability. The next is the internal consistency reliability, which is the most important part of the reliability. Because nowadays, when we talk about reliability, we are checking only the internal consistency of the script. So internal consistency meaning is very simple. We are generally say this thing, that this internal consistency indicates the degree of homogeneity of the items in the instrument or scale. Homogeneity means similarity, right? So whenever you want to check what is the similarity or what is the degree of similarity in the items or in the questions, you will use internal consistency reliability. So it tells you up to what extent a test is internally consistent, or to what extent there is a good amount of balance or correlation between the indicators, dimensions of the construct. So here you can see there are 2 terms coming. Construct meaning is what? Constructs are generally latent in nature. Latent meaning is which you cannot directly measure, right? So here you can say, I have taken an example. Suppose there is a scale of motivation. So we know motivation is a variable we cannot directly measure, right? So I think yesterday I have given you an example of satisfaction, where I said this thing. We cannot say this thing that I am having 1 liter of satisfaction. There is no unit of satisfaction. Similarly, I cannot say I am having this much motivation or I am having this much motivation. So there is no unit of motivation or scale of motivation available, right? So what you can do, you can use certain number of questions to understand the level of motivation in any particular person, right? So that way you are developing certain questions to understand the motivation. So that way you can say motivation is a construct. It's a latent variable which you cannot directly measure. So you need to take the help of certain indicators or certain dimensions or certain items, right? So that way we can say that we can measure that whether the items which we are taking to calculate or to measure the motivation, whether those items or dimensions are consistent or not, are similar to each other or not. Although means it should not like if suppose I'm telling this thing, I'm feeling very good when someone is asking me that how was your day, suppose, right? So this is suppose I'm feeling motivated. So it is not like the whatever sentence I have written in the first question, the same second question will be similar, but almost there should be certain similarity in the questions. And we know because correlation is nothing but it is indicating in a relationship. So two things will be related only when they are sharing certain type of relationship with each other. So that way, the items or the dimensions which we are taking to measure the motivation, they should be having certain correlation among them. They should be related to each other. That way, you can see, I'll explain you using an example here. So in this, you can find this is the motivation. Motivation is your construct or your latent variable, right? So to measure this motivation, suppose we have written 10 items or 10 questions I am having, x1 to x10, right? So meaning is very simple. These all 10 items or these all 10 dimensions should be related sufficiently. There should be a fair correlation among all the 10 items. That way we can say the motivation scale is consistent. Fine. So this is known as internal consistency when the items are correlated to each other. I hope till here I am clear to everyone. Is it fine?
Yes, ma'am.
Is there any question which can show us that items or that questions are irrelevant?
Sorry?
Is there any example so that can show that items are totally
There are so
irrelevant?
many skills available. You can go on Google and you can identify. So you will get the questions also, right? Suppose there is a scale known as the service quality scale is available, which is developed by the Pursuit, right? So on the particular scale, there are 5 dimensions: tangibility, reliability, assurance, empathy, etc. So that way, suppose I'm saying tangibility. So if I'm saying service quality scale meaning is services, the scale which can measure the quality of the services. And we know services are intangible in nature. So how you can tangibilize your services? So that way you can ask certain questions. So there are scales available in the Google. You can go and search the scale. That way you can find the scales and that way you can see their sentences, right? But here for making you understand, I'm just showing you this thing that whatever is your construct to measure that you can take certain number of items. Whatever items you are taking, they should be having the fair level of correlation among them. So that way you can say your scale is the consistent scale. Fine?
Okay, ma'am.
Yeah. Now, moving ahead, talking about, as I said, internal consistency is nothing but it is one of the methods of reliability, which can help you to measure the what I can say consistency among the items. So, which particular what I can say coefficient or the measure you can use to measure the internal consistency? So the name is convex alpha. So I think many of you have already heard this particular measure, which is known as convex alpha. Convex alpha is a very popular measure which we are using to check the internal consistency of any particular scale. This particular convex alpha was given by the American psychologist Sir Lee Cronbach. So after his name, he has given the name to this coefficient as Cronbach's alpha, right? So in the year 1951, he has given this particular convex alpha. So as I said, this is generally used for understanding or measuring the inter-item reliability or the internal consistency, right? So it is very popular. You can understand this thing with the help of this, but whatever value you are getting of the Cronbach alpha, using that value, you can understand up to what extent your indicators are correlated or related to each other. This is what you can check using the Cronbach's alpha. Then when we talk about for which kind of variables you can apply Cronbach alpha, so mostly means most important is you need to generally have the continuous data, or you can use the means I can say you can take the help of Likert scale data also. So for dichotomous data also you can check the or apply the Cronbach alpha. So whether it is a continuous data, that is numeric data, or whether it is a categorical data, in both the cases Cronbach alpha is applicable, but you need to have the values in the form of number, right? So that way you can check the Cronbach alpha. Now, talking about the formula, usually there is no meaning of discussing the formula, but still I am showing you there are two methods in Cronbach alpha. One method is based on the variance, and the second method is based on the correlation. So today I will talk about the correlation because it is the mostly used method. As I think I discussed in case of the types of reliability also, I have shown you this thing that always we are generally calculating the coefficient of correlation. So we are considering a Cronbach alpha method, which will be based on the correlation method, right? You can see the various formula are listed here. The source is also mentioned here. From these sources, these two formulas were picked up, right? Next, interpretation of Cronbach alpha. So I will read this table from the bottom, and then I'll go to the top. So here if I say that alpha is less than 0.05, meaning is the reliability is unacceptable. You cannot accept a scale which is having the alpha value less than 0.5. 0.5 and 0.6 means if your alpha is lying between these two values, that means it is an indicator of poor reliability. If the alpha value lies in between 0.6 to 0.7, your reliability is questionable. Then 0.7 to 0.8, in between 0.7 to 0.8 indicates acceptable reliability. 0.8 to 0.9 alpha is a indicator of a good reliability. And if your alpha is greater than 0.9, it is excellent reliability. But here there is a problem if your alpha is greater than 0.9. And problem is what? This problem is known as multicollinearity. Because if I'm saying that the correlation value is 0.95 or 0.98, so alpha is looking very pretty good. That means you can conclude this thing, your scale is the reliable scale. But the problem is that when we are saying that Cronbach alpha is 0.99 or 0.95 something, so that means, as I said, Cronbach alpha is nothing but it is a coefficient of correlation. So if coefficient of correlation is very near to 1, that means it is very clear indication that your all the items are almost similar. They should not be very similar. They should not be almost similar, but they should be having sufficient, or I can say fair level of correlation among them, right? So that way you need to see this thing in which pair of items the correlation value or Cronbach alpha value is coming greater than 0.9 or something. So that way we can take a decision of dropping those items, and that way we can again perform Cronbach alpha to bring it to little lower level, right? So that way this is you need to keep in your mind. If your alpha is coming greater than 0.9, so that means there can be a chance that your items are very similar, right? So that is why the people, those who are responding to a question, they have given the similar type of responses because the concept of correlation is very similar. If I say there are certain values and same values I am copying in the next column also, and if I will find the correlation, it will always come as 1 because items or the values are very similar to each other. So if you are moving if your value of Cronbach alpha is moving to 1, that means there is a problem. So it should be like 0.7 to 0.8 is okay, right? Means greater than 0.9 is a problem. 0.8 and 0.9, between 0.8 and 0.9 is also fine. Now, talking about how to perform Cronbach alpha and SPSS, I think these are the steps which I can skip. Acceptable range, I have told you 0.7 to 0.9. Talking about how to improve Cronbach alpha, right? So, if suppose there is some problem is coming in your Cronbach alpha is not like it's pretty good, right? So, what you can do, you can improve your Cronbach alpha value. How you can improve your Cronbach alpha value? So, there are methods to improve. The first one is you can diagnose the missing values in your data. Second one is you can see the removing of ambiguity and the redundancy in the items. And the last one is you can diagnose item total coefficient. So these are the three methods using that you can improve your Cronbach alpha. Very first one is you need to see, suppose I am having 10 or 15 questions to measure a particular variable or particular construct. So in that case, I need to identify if any particular item is having so many number of missing values. Meaning is very simple, that either the respondents have not got the clarity what to respond to that question, or maybe they do not want to express their responses to that question. So in that case, you can take a call to drop this type of item. So that way it can improve your Cronbach alpha. Second one is you need to check properly whatever statements you have written to measure your variable. If there is any ambiguity, means if there is like double meaning type of sentences you have written, or there is a repetition of the sentences in the questionnaire, in that case also you can get the poor Cronbach alpha value, right? And the last and the very important one is the diagnose atom total correlation. This I'll show you once we will perform the reliability using the SPSS. So there you need to see what is the acceptable value of item total correlation. The very first thing is it should not be negative, right? This value should not be negative. First thing. Then if you can talk about if all the values are positive, if item total correlation values are positive, right? So what is the threshold? So this should not be less than 0.3. 0.2, 0.3 is okay. If the item total correlation is less than 0.2 even, in that case also you can drop that item from the scale, and that way it can improve your Cronbach alpha value, right? So these are the certain things or certain what I can say ways of improving Cronbach alpha. Next slide is for the normality. So I think I will take firstly the performing of the Cronbach alpha or performing of the reliability using the SPSS, and then we will move for the next concept, that is normality, right? So I think I have shared the what worksheet today with all of you. I hope you have received. It is available there on a WhatsApp group. I hope you have seen.
Yes, ma'am. We received. Yes, ma'am. Thank you so much.
Thank you, sir. So, sir has seen. I hope the remaining one has also seen the sheet which I have provided you. I'm expecting you open, download the sheet and please open it. Those who are having the what I can say SPSS, they can perform the reliability along with me. Or the remaining one, I think they cannot see, they cannot open the file which I have given, because it is .sav file. .sav is the extension of the SPSS file. So in that case, you cannot open it because it will not be supported by your desktops or your laptops, right? Is it clear? So give me a nod.
Shared on a WhatsApp group.
Yeah.
I'm not added maybe in that group. I'm not received. I'm not added in that group. I've not received any file.
So I think usually RFI sends the WhatsApp group link on your mails, whatever mail you have used to join this activity. So probably you have received that link on your mail, ma'am. So you can check your mail. Yuvraj sir, are you there? Sir, can you share the WhatsApp group link here in the chat? Yeah. So Ketki ma'am, sir is sharing the WhatsApp group link. You please join that.
Yes, ma'am.
What about the remaining one? Have you people downloaded it? I think link is available there in the chat. I hope you got Ketki ma'am.
Yes, ma'am. Now received. Joined also. Ma'am, but I have not got the file. Can you share?
So may I request anyone? May I request anyone who can share the link there in the group? Can you share the sheet again? Anyone? I hope everyone has received the same.
Yes, ma'am.
I think Nora sir has shared the notes also in a WhatsApp group. For those who are coming along with me, I am expecting them to please download the sheets and please open the sheet. Right? Shall I start now?
Yes, ma'am.
Fine. So I'm sharing my screen now. I think I have opened the sheet. So I have given you a sheet which is named as customer satisfaction towards restaurants. I hope you people have opened it. Opened it, everyone.
Yes, ma'am. We can open.
Fine. So shall I start discussing this? Yes, I hope everyone is ready.
Not yet open.
Do I need to wait?
Not opening, ma'am.
Ritki ma'am, are you saying something?
Yes, ma'am. It is not opening. I'm joining from mobile. So maybe it is mobile. So that's why it's not opening.
Mobile will not support it, ma'am. This is SPSS is a software. It should be available there if you want to use it. So it will not be available there in your mobiles, right? So you need to open it through your laptop. If there it is available, right? Fine. Okay. So now I talk about the data set. Here you can see. Here I have given you certain number of questions. I think almost there are total 31 questions listed. I think I am on a variable view where you can see we are having total 31 questions and all the questions are named. I think I don't know who has asked me regarding the questions. So ma'am, I think you can see the questions are listed here. Modern equipment, physical facilities, neat appearing, materials visually appealing, likewise, right? So these are the meaning of the question. And then you can find all the questions or the data was collected for all the questions on the 5-point Likert display, right? Once you click on this, it is showing you one is for the strongly disagree, 2 for disagree, 3 for neutral, 4 for agree, and 5 for strongly agree. Is it fine?
Yes, ma'am.
No. So this way, this type of Likert scale, 5-point Likert scale data is given to us. All the data is coded here, so that is why we have taken the type as numeric. Now, coming here and talk about how to perform here the Cronbach alpha. So I am expecting you to please note it down. You can go to the analyze, then you can go to the scale, and then you can select reliability. So you can, I hope everyone has noted it. Noted, everyone?
Yes, ma'am.
Done. So now what you need to do, once you will click on the reliability analysis, it will open a reliability analysis dialog box for us, right? I hope you can see it.
Yes, ma'am.
You can select all the questions, right? I'm taking it as variable names. I converted this into the variable names. Then you can select all and you can shift all of them into the right hand side box using this arrow key. Then I hope done.
Yes, ma'am.
Now, there are various different methods available in the Gutman parallel half strict parallel, right? So now nothing you need to do, but still if you want, you can click on this statistics button. There you can find, if suppose I'm selecting this item, scale, and scale if item deleted. These three I am section which is descriptive for. This will give us a descriptive for the item, scale, and scale if item deleted. Done, everyone? Fine.
Yes, ma'am. Yes.
May I proceed?
Yes, please.
Yeah. Now you can click on the OK button to get the output. So, sorry, click on the continue button where your will be generated and your results will be coming in the output viewer. So you can see in the next. Or I hope it is visible to everyone.
Yes, ma'am. It's visible.
Yeah. Now you can case processing summary, which says we are having total 121 observations, right? Then nothing is excluded. 120 items were considered, right? So this is the meaning of this particular table. It is clear? May I proceed to the next?
Yes, ma'am.
Now you can find it is giving me the reliability statistics, which is in and the number of items were 31. So I think you know we have taken total 31 items, 31 variables, and then we are seven, right? Now further I'll do and talk about the next one, which is the item statistic. This is the descriptive statistics of all the items. So all the 31 items are listed here. You can find the mean for each of the item, standardization for each of the item, and total observations were used here for calculating the mean and the standardization, right? Go down, and this table is a very important table. This table will help you to understand deleted. So here you can find if I will delete this item, that is modern equipment. If I will delete this, so the entire scale mean will come as 96.74. Similarly, if I will delete the question for physical facilities, so my scale mean will come to the 94.79. So likewise, we can delete this column. Similarly, if I will delete the first item, so the scale variance will be 147.242, right? The next thing is the corrected item total correlation. So if you can recall, this is I discussed when I have explained you the slides. There I told you firstly you need to check this should not be negative. Means for every item you need to firstly check this thing that this value should not be negative value, right? So I think you can go down and you can check whether it is positive and negative. So I think all the values are positive. The personalized services, we are getting the Cronbach alpha, we are getting the item total correlation as a negative value. I hope you can see I'm rotating my mouse here. Right.
Yes, ma'am.
So first of all, what you need to do, you need to take a decision to drop these two items firstly, and then we will check whether there is any impact of dropping these two items on the reliability value, right? The next thing is the next column says convex alpha if item deleted. So we will check this also firstly, and then if I will first item, so my come to the 0.675, and then you can see our convex alpha was 0.672. Means there will be little improvement if I will drop the first item. If suppose I am dropping the second item, this will come as the convex alpha value. So likewise, you can go down and you can find. After looking all the convex alpha value listed here, if I will delete any of the respective item, I will not get the convex alpha even 7 because it should be at least 0.7. Only then you can say your scale is a reliable scale. So the next thing we will do, we will consider the corrected item total correlation, which is indicating for the two items this value is negative. So we will firstly read this attentive attitude in the personalized services, right? Is it clear?
Yes, ma'am.
So you go to the analyze, scale, and the reliability analysis, right? I'm selecting all and then sending them back because meaning is because I am unable to identify the variable with this question 1, 2 or something. So I have converted, I want to display them by the labels. So I am shifting them again. Now I need to drop question number for the this one. Attentive attitude and the personalized service. This is question number 23 and question number 24. I hope everyone has got or located these two. Fine, everyone?
Yes, ma'am.
So you can shift them back. So I'm shifting both the variable back. And then nothing you need to do. Only you need to drop them and you need to perform on the same process again. So I think you have seen we have not made any changes. So here in this, these three are already selected, which we have made. You need to only in the same window you will get the item. Yeah. Now you can see there is improvement in your convex alpha, which is 0.701. I hope it is visible to everyone now, right?
Yes, ma'am.
So that means this way you want to make more improvement in your convex alpha. That decision you need to take whether 3 or 4 questions will also be dropped here by you to make it or to improve it, right? So that way again you will go, you will cross check these values that if there is now all the values are positive. So now we will find the least least corrected item correlation value, item total correlation value. So what is the very small value? Yes, you can identify. I think it is 0.009. I hope this one is it for the on-time survey. Is it right?
Yes, ma'am.
So further, you can take a decision to drop this. So this will be totally a call of the researcher that how much improvement you want to make in your convex alpha value. And whatever the number of items minimum you are requiring to have in your script, that decision will be taken by the researcher. So this way you can check or test the reliability using this particular SPSS. I hope it is clear.
Ma'am, if researcher don't want to reduce the number of questions, but want to do the improvement, so can he or she introduce the new questions there?
That you can do. Even you can check your whatever statements you have made. So you can check whether all the statements whatever you have made are clear to each of the respondents or not. There should not be any ambiguity. So you can take the advice of your experts, and that way experts of that field can maybe guide you to maybe reframe your questions, and maybe possibility reframing of the questions can improve the value of your convex alpha.
Yeah. Cheap.
Okay, so I think this is about the reliability. Now we will talk about the next concept, which is the normality. So I am again switched to the slides. I hope my slides are visible now. Visible?
Yes, ma'am. It's visible.
That many of the statistical tests, especially the parametric tests, are demanding for the normality of the data, right? So you need to understand the concept of the normality. Normality is nothing, but it is the that the distribution, whatever data you are taking, it should be equally distributed to your mean. Because when you talk about normal distribution, I think you have seen how to depict the normal distribution. This is depicted by a bell-shaped curve, right? And middle of the bell-shaped curve is indicating the mean, right? So it is like 50% data should be left hand side of the mean and 50% data should be right hand side of the mean. This is the assumption generally we are taking. That way it is known as the normality. Apart from that, there are certain properties of normal distribution or normality. The very first one is the mean value should be 0, standard deviation value should be 1, right? And the skewness value should be 0. Kurtosis value should be 3, right? Please, you need to check of your data. That way you can ascertain this thing that your data is normal or not normal. Accordingly, you will select your test also. So normality assumption is very important from the point of view of the parametric test. So that way you need to check this normality assumption for your data, for your variable. So there is a difference in reliability and normality here. Reliability, we are checking for the entire space. Normality, we are checking for a specific variable, right? Whatever variable you are using for your hypothesis testing, for such variable, you are testing the normality of that variable, right? I hope it is clear. Yeah.
Yes,
Now,
ma'am.
talking about there, as I said, there are two main important, what I can say, component of the normality. When we talk about this bell-shaped curve, so this bell-shaped curve is having two parameters. Skewness parameter meaning is using the skewness and kurtosis, we can understand the shape of the bell-shaped curve, right? Here you can see, if I talk about the skewness, right? So skewness is like the middle graph you need to see here. If your data distribution is coming like this, means if you are fitting a normal curve on your distribution of the data, so that way all the data points are coming under this curve, and your middle is lying at the middle of this particular curve. 50% data is at the left, 50% data is at the right. That way you can say there is no skewness in the data, right? Skewness meaning is symmetry. Symmetry meaning is very simple. If you are making like this, means there is a overlap. If I will fold the right side to the left side, so that means should be overlap. There should be an overlap. So that way there is no skewness in the data. But you can see the left side. That means there is a tails. These are known as the tails. These two are known as the tails of the bell-shaped curve. So if there is any what I can say, a mismatch in the tails. If your left tail is greater than your right tail, that is the indication your data is negatively skewed, right? Similarly, if your right tail is greater than your left tail, your data is known as positively skewed data, right? You can see its characteristics. In case of this negatively skewed data, your mean will be always lesser to your median, and median will be smaller to your mode. But in the normal distribution, usually mean, median, and mode, all three are similar. In the positively skewed data, your mean will be higher, median will be less to the median, and mode will be less to the median, right? That means in case of negatively skewed, mean will be very low, and in case of positively skewed data, your mean will be very high. Is it clear?
Yes, ma'am.
But here in the diagram, mode is looking like higher one.
No, ma'am, you need to see the value. We are going to the positive scale, no? This is the
Yeah.
positive. So the mode value, mean value will be high value.
Correct one, correct one. Yeah.
Yes. So I hope I can proceed. Yes.
Yes, ma'am. Yes. So sorry.
No, it's fine, ma'am. This is totally like we are learning from each other. No problem. Yeah. Now we will talk about the methods which we can use to check the normality. So usually there are two types of methods. First one is the numerical methods and second one is the graphical methods. Using these two methods, we can check the normality of the data, right? So in the numerical methods, we can take the skewness, we can take the kurtosis. Using these two, we can ascertain the normality of the data. Apart from that, there are two tests which are known for the checking of the normality, and these are the Kolmogorov-Smirnov test and the Shapiro-Wilks test. Using these two tests, also you can check the normality of the data. In the graphical section, if I want to check the normality of the data using the graphs, so there is a graph known as histogram, QQ plot, and the box plot. So these two we can use to check the normality graphically, right? So these are the 6 methods using that you can check out the graph. I normality of the data. Further, talking about the histogram, I think every one of us no gap in the bars. Apart from that, whenever I say histogram, we are using for the numeric data, that is the continuous data, right? Bar graph is used for the categorical data. Histogram we are using for the continuous data. So this is indicating you the distribution of the data. If you can recall the shape of the histogram, I think I have taken. Yeah. If you can see here. I will talk about the histogram. So that way you can see on the x-axis we are taking the variable, right? The variable which is continuous, and on the y-axis we are taking its frequency. So this is indicating you. Suppose I said from 10 to 20. So whatever number of observations are falling in the 10 to 20. So this is indicating this size or the length of the or you can understand this in Excel using SPSS also we can create or make the histogram, right? Looking at the diagram or looking at the histogram shape, we can understand the normality of the data. So if I talk about the very first the left side graph, which is at the which is at the upper side, left upper side, you can see if this type of histogram we are getting. So that way you can see your data is a skewed data.
Correct.
Any question?
Ma'am, please repeat.
Yeah, I said if I am talking about the distribution of the data using this histogram, right? So we can say if I will put a bell-shaped curve on this, so it is a clear indication that your left tail will be higher or the bigger than your right tail will be the bigger tail in comparison to the left. That means your data is the skewed data. It is right skewed or it is the positively skewed data, right? Apart from that, if you will find a histogram like this, if there are two peaks coming, double peak means there are two bars which are very highest bars. That means this type of distribution is known as the bimodal perfect normal distribution. Again, this is a skewed data. You can call this data as a positively skewed data. And the last one which I am talking about, which is known as where you can unable to find any kind of pattern in the data. Graphs are not properly indicating any particular, what I can say, shape. So that way we cannot comment on anything on the normality of the data looking at this last graph, right? Further, there is one more depiction of histogram you can find. As in this, because the images these I have taken from the net itself, right? So that way you can find whatever I have got to make you understand, I have taken there. But one more image I have taken here of the histogram. Looking at these images you can find. If I will talk about the histogram, right? You can see these blue portion is the portion which is made by this histogram, and then we have kept the bell-shaped curve on this particular graph, right? So that value should be status of your x-axis. They are coming very upper. They are going on means they are not coming very close to the x-axis, something like that. That is also indication of the that normality is poor or normality is okay of your data. So you can find the next method is the QQ plot. Here you can see, if I will talk about the first left hand side, left upper side, if I will say, this is the first QQ plot. QQ plot means the quantile plot, right? So this is indicating you if you are fitting a right side. That means your ball data is the left extreme, that right? One is the mesocortic data, right? And if it is forming this kind of similarly, if I will talk about the thickness of the tail, thickness meaning is more data points are falling on your tails. Thin means less data are less data numbers or less data points are falling on the tails. So if I will talk about this, you can see the D graph, which is indicating this is indicating your tails are thick. That is your data is leptokurtic, and this is indicating that your tails are thin, and that way it is known as the platykurtic data, right? So according to the graphs also we can understand the normality of the data. And the last one is the box plot in this category. So box plot is having 5 components. The very first one you can see in this box there is a middle line, dark middle line, right? This middle line is nothing but this is known as the median of your data, right? The upper wall of the box is known as third quartile. The lower wall of the box is known as the first quartile. Then the remaining portion, this portion is known as the upper whisker. This portion is known as the lower whisker, right? If certain data points are exceeding these whiskers, maybe you can find certain data points are indicated by this circles. That means this is indication of the outliers in the data. So these are the upper side outliers and these are the lower side outliers, right? Now, how to calculate whiskers? So I think I have taken the formula here. Using these formula, you can calculate the whiskers also. But there is us all the no need when we are using will be taken care by the software for us, right? Students, I think I have talked whether your data is symmetrical or not to your mean that you are using or measuring using the skewness. There are 2 types of skewness, positive skewness and the negative skewness. If the value of the skewness is coming positive, you will call it as a positively skewed data. If it is coming as negative, you will call it as a negatively skewed data. Because for the perfect normal distribution, skewness value should be 0. Kurtosis, as I have shown you, according to the graph, you can see the black curve. If you will look at, this is the perfect curve, which is known as the normal curve, right? This is known as the mesokurtic curve. But the blue one, if I will talk about, this is known as the leptokurtic graph or leptokurtic data. This is the positive kurtosis. Leptokurtic meaning is your kurtosis value is coming positive. You can say that the kurtosis value will be the negative value, right? So your the curve will be very flatter type in case of platykurtic or negatively negative kurtotic data will be like this. So proceed for the next now. Yes.
Yes, ma'am.
Yes. So I'm expecting you to open the second sheet which I provided you. Named as bank loan, I think, right? Which sheet I have given you, bank loan? Please confirm so that I can open the same sheet. Anyone? Please check on WhatsApp what I have given to you.
And first is about bank group, and second one is customer satisfaction.
Customer
toward
satisfaction, I
restaurant.
think we have already used. Yes. Thank you so much. Okay, so I'm the same sheet. Yes. Thank you. My screen now. I hope it's visible to everyone.
Yes, ma'am.
Yeah. So whenever we will talk about normality, we are talking the normality of the numeric variable or the continuous scale variable, right? So you need to check the normality of the numeric data, right? So in the variable view, you can identify whatever the variables available with all of you. Although all the variables we have taken as a numeric, but actually these are not numeric. Age, education, if I will talk about, you can check. Education is not a numeric variable, it's a categorical variable. We have coded this data, right? Similarly, maybe age, I can check. Age, we can say it's a numeric data, right? So now you can see all the variables listed here are not the numeric. Some of them are categorical, but we have coded them. That is why we are saying these are these. That's why we have said their type as a numeric, right? So one of the numeric variables I am picking here. So which variable I need to pick? Anyone?
Could you please repeat
Which
the question?
variable I should select here for checking the normality?
Yes, income.
Fine. So we will take income to check the normality, right? So I'll guide you the steps that how you can check the normality for the income variable. So go to the analyze, go to the descriptive statistics, and then go to the explore. I hope you got it. Everyone located the same?
Yes, ma'am.
Fine. I am selecting this explore. So the explore dialog box will appear. Here what you need to do, you can find at the left hand side, all the variables of the sheet is available here. You need to pass your variables in these boxes. Not necessary to pass factor variables always, right? But for the normality, we need to pass at least the dependent variable that is the numeric in nature. So I think ma'am said we need to check or take the income. So I'm selecting this household income in thousands and shifting into the dependent list. Done?
Yes, ma'am.
Now you can click on the statistics button. There you can find by default descriptives is selected. So we always calculate the descriptives as we are considering spinach and kurtosis, etc., which is the part of the descriptive statistics. So we will go with the by default option and click on the continue. I hope it is done.
Ma'am, can you repeat this step, please?
Nothing. Statistics, I have just shown you. Nothing you need to do. We will go with the by default option.
Okay.
Then you need to select the second one, that is the plots button. Once you will click on the plots button, a dialog box is appearing for the explore plots. So box plot we need to make, right? So by default, if you do not want to make box plot, you can click on the none also, right? If you want to create the box plot, so by default option is the factor labels together. If you want to make them different, if you want to create the box plot for the different label, the different place, that way you can go with this also. Suppose we are going with this particular option only, right? Coming to the descriptives option, here as I told you, there are certain graphical methods are also available for checking the normality. So one is the stem and leaf, which is very old method. Nowadays, nobody is using this method. So we will deselect this and select the checkbox. Then
Yes, ma'am.
now you need to select on the normality plots with test. So apart from the test, you also want to create the normality plot, right? So this is what you need to do here. And then you can press on continue. So I hope I can. Done?
Yes, ma'am.
So you can click on the continue, and then you can find it is indicating you display whatever display you want. Whether you want to only see the statistics, you can select the statistics. If you want to see only the plots, you can select the plots. But if you want to see both, you can select the done. By default, yes, yeah. By default, it will give you the both, and then you can press on OK to get the output. I hope you got the output.
Yes, ma'am.
Okay. So now you can check here. If I talk about the first table, which is the case processing summary table, there you can find there are total 850 observations and there is no missing value in that data. So your total is 850. Coming to the next table, which is the descriptive statistics table, there you can find the mean value of the income is the 46.673, right? The 95% confidence interval for mean, lower and upper bound is coming as 44.08 and 49.27. The meaning is that if you will pick any other sample from the same population, so chances of the mean income falling will be in between in this range, right? If you will take some other sample from the same population and you will calculate the mean of that of the income of those people, so the mean will fall in this particular range. Is it clear?
Yes, ma'am. Yes, ma'am.
Then 5% trimmed mean. 5% trimmed meaning is very simple. When you are removing 5% outliers from your both the sides, upper side and the lower side. So I have shown you the box plot if you have seen. So in the box plot I have shown you beyond the whiskers there were the circles, right? Those circles are the indicator of the outliers. So in that case, if suppose if outliers are available in your data, so 5% means it is trimming the outliers, right? And then it is calculating the mean. So it is coming as 41.517. So that way you can compare with the combining of all the observation mean is coming as 46.67. But when you are trimming the outliers, it is coming as 41. That means it is indication that there are outliers available in your data. Then median is 35. Median income is 35. Variance of the income is 1485.567. Standard deviation is 38.54. And then minimum income is 13 and the maximum income is 446. And then range is 433, which is the difference of maximum and minimum. Interquartile range, which is the difference of third quartile and first quartile, which is coming as 32. Skewness is 3.701 and the cutoff is 22.486. So as I said, skewness should be 0 and its cutoff should be 3 if we want to say that data is normally distributed. So you can find both the cases are not applicable here. Similarly, one more characteristic is there, mean and median and mode should be equal, although mode is not calculated by this particular way, but it is indicating mean is this and median is this. Both are not same. Right? There is a large gap. That means there is a problem. Fine?
Yes, ma'am.
So, this way maybe we can say this thing, looking at the experience in kurtosis, we can comment that income is not normally distributed. Coming down, there are two more methods if you can recall I have talked, that is the Kolmogorov method and the Shapiro-Wills. So if you are making your notes, please write the hypothesis for these two tests. Yes? Fine?
Yes, ma'am.
Yeah.
But how can we comment on the basis of these two tests at the last that you have mentioned? That Shatrughat
Please
and
write the hypothesis, then I will tell you.
okay.
Now, please write the hypothesis is the null hypothesis I'm telling you, that is H0 or H0, which is variable is normally distributed. Done? Noted, everyone?
Yes,
Fine.
ma'am.
So if I am saying variable is normally distributed, I need to see the p-value. Always in when we are testing the hypothesis using the software, we are considering the p-value. P-value is the significant value, SIG, right? So you can see the significant value here in case of Kolmogorov-Smirnov and in case of Shapirovich's test. So in both the cases, it is 0.000. Generally, we are testing the hypothesis or comparing the p-value with the level of significance. So suppose we are assuming that we want to test the hypothesis at 5% level of significance, right? So that means you need to compare the p-value from the 0.05. 5% meaning is 0.05, right? So if I will compare the p-value with 0.5, with 0.05, that means it is an indication that your p-value is less than 0.05. So if you are through with this comparison, it is fine. But no, if not, so you can note down the thumb rule of the p-value. You can write thumb rule for the p-value. I hope I can say. Noted,
Yes, ma'am.
everyone? So the rule says if p is less than 0.05 or if p is less than level of significance, you write if p less than level of significance, then reject H0. And vice versa case, if P is greater than level of significance, accept H0 or null hypothesis. Is it okay?
Yes, ma'am.
Fine. Now, if we will look at the significant value, which is less than 0.05, so we are commenting that we will not accept the null hypothesis. And I think you have written your null hypothesis as variable is normally distributed. That means we can comment that income is not normally distributed because we are not accepting the null hypothesis, right?
Yes. Okay.
So that way, with the help of squamous kurtosis and with the help of Kolmogorov and Smirnov and Shapirovich's, we have ascertained this thing, right? Going down. Looking at your histogram. If you will look at your histogram, it is a clear indication that your salary is not or income is not normally distributed, right? It is positively
Yes.
right? Now, if I want to put a bell-shaped curve on this, what I need to do? So you please double click on the area of this curve. Double click you need to do, and you will be landed on the chart editor. I hope you are here on this chart editor with me, right?
Yes, ma'am.
Now you can find there is one main bar is coming, and then there is a next bar is coming. In this next bar, if you can see the second last option, I hope it is visible to everyone. This is for the show distribution curve. Visible, I hope, right?
Yes.
You can select this, and then it will be land you on the properties box. There you can find by default normal distribution curve is selected. You need to only close this, right? And that way you can find in the chart editor, this is the bell-shaped curve placed on your histogram, right? You need to only close this and you can see there in the output viewer on your histogram, you can find this is the curve which is fitted, right? Fine, everyone?
Yes, ma'am.
Fine. So looking at the bell-shaped curve, you can see bars are exceeding the bell-shaped curve. Also, the right tail is greater than your left tail. So that means your data is positively skewed. That you can ascertain looking at your skewness value also. Skewness is positive, right? That means your data is positively skewed, and kurtosis is positive. That means your data is leptokurtic data, right? So there is a problem with the normality of the data. It is clear?
Yes, ma'am. Yes, ma'am.
Yeah, go down looking at the QQ plot. So you can find QQ plot. I told you if QQ plot, this curve is coming at the left side, that means your data is rightly skewed data. So I think this is what we have ascertained using the histogram also and using the values of skewness and kurtosis also. Going down, this graph we do not need to explain or discuss. We will go down and we will see the the box plot. So once you will look at the box plot, you can find there are so many outliers available at the right side. I think that we have seen in the histogram also, right? Because the tail was higher, right? Or the larger. So same you can find, that is why we can find the upper side of the upper whisker. We are getting so many circles and aspects. Hello? So that way you can find these are the indication of the outliers in the data, right? So that means your data is positively skewed data. That means you're looking at the box plot also, we can comment on the normality of the data. Is it clear to everyone?
Yes.
And you can compare the whisker size also. So whisker size is, this one is lesser or smaller than the upper whisker. So that way it is indicating the right tail is greater than to the left tail. So this way we can ascertain the normality using the various methods. Depending upon the researcher, depending upon the users, if they are comfortable in all the methods, they can use. But if you're not comfortable in what I can say, interpreting the graphs and all, what you can do, you can take the help of the numeric methods like skewness, kurtosis, because you need to compare only those values with the threshold value of which variable is normally distributed or compute, right? So this is all. I will summarize my session with this note, that when we talk about the reliability, reliability is a very important aspect when we are talking about a construct, right? Means once I am saying, as I said, suppose I want to measure the perception, or I want to measure the satisfaction or motivation, etc. So these are the single thing which I am measuring using so many items, because there is no particular apparatus available using that I can measure them. So I need to take the help of certain number of items of questions, using that I can measure them. So you construct, and that way you can make a scale, and you internal constructs methods. As I said, if you are using Likert scale data for internal consistency, that you can use or check using the Cronbach's alpha. I explained you the interpretation part of alpha. Usually alpha should be greater than 0.7 and should not exceed 0.9. If it is exceeding 0.9, that means there is a problem of the similarity in the data, right? That your items are very, very similar. If I'm asking same question in some other way, it is quite obvious. Usually I will get the same response, right? So that way, you need, that will lead to the multipolarity. So you need to see this thing to solve the problem of the multipolarity in the data. And then I have explained to you how you can improve your value. So there are certain methods like you need to check the missing value, and then there is a method called items, or whether identical correlations are positive or not. If there is negative identical correlation, you will drop that item first, and you will recheck the reliability using the Cronbach's alpha, and then that way you can take a step. That way you will move to the positive value, and you will select the most least or most small or minimum value, and then you will drop it. So that way you need to decide upon how many items you want to keep in your scale and how many items you can drop, right? And that next thing, that how much Cronbach alpha value is required by you. So accordingly, that way you can take your decision. So this was about the reliability. Then I discussed the normality. There I talked about what is the normality, why it is important, and then what are the methods that I discussed the numerical explained you using these methods we can check the normality of the data, and then we can proceed further for applying any statistical test using the SPSS or using any other software, right? So this way, this was the crux of this session today. Now I think platform is open for questions and answer. If you are having any, please ask me.
In your study, you came out with the conclusion
You should not go for the parametric test, right? But if suppose you want to perform parametric test, so you need to find there are certain tests which means they are what I can say is still the normality is violated by your data. Still you can perform them, right? Because there is a concept of the central limit theorem in their statistics. The theorem says if your data is sufficient and your data is greater than 30, that means your data is tending towards to the normality. So many times if you will read the research paper, you will find people are not reporting the normality, because if you are taking 100, 200, 300 sample size, so people are assuming that your data is normally distributed, right? So that way also you can take a decision. That will be your call, because answerable will be we only if you are submitting your work. And if suppose the reviewers are asking you certain questions, so that will be their call, but you should be ready. If you are ready, you can give the answer, you can justify the things, so they'll accept your work.
Thank you, ma'am. Thanks a lot.
Thank you, ma'am. Any other question? No question? To find, right? Tomorrow we will meet for the next session. Is it fine, everyone? Okay.
Thank you, ma'am.
So thank you, everyone. Yeah, thank you, everyone, for your patience listening along with me
Thank you, ma'am.
and learning. But I don't know today how many of you have performed along with me. But I hope many of you have performed, because it is like any software. If you are learning, it will come only with the practice, right? Fine, everyone.
Yes, ma'am.
Yeah.
Yes, ma'am.
Thank you.
Nicely explained by you.
Thank you so much, Kavita ma'am. Okay, so Yoga sir. Yoga sir, are you there? We are done for the session today. Okay, so I think I can leave the meeting, friends. We will meet tomorrow now for the next session. Thank you, everyone. Good night. Take care.
Thank you, ma'am. That was a great session.